Electron configuration is a little bit different than what we were doing before with Lewis structures and Bohr models. So let's talk about electron configuration. And the easiest way is kind of to model it with some boxes that will represent our energy levels and some circles that will represent our electrons. So let me just draw a few. Actually, let me erase this one. So you might want to write these down for yourself so that you know what exactly is going on when you have to actually do some activities with electron configuration. So if we make these pink circles our electrons, so circles equal electrons, and these boxes represent energy levels. So the energy levels that we will talk about first are S, P, and D. So here is 1s, here is 2s and 2p, here is 3s, 3p, 3d, and the reason that this one right here is kind of hashed out is this is actually 4s. So the weird thing is sometimes we'll fill up the 4s energy level before we do the 3d. So this will be a little bit confusing, but just keep on with it. Make sure you write stuff down, re-watch if you need to. So if we were to look at a neon atom, so let's say we have neon. And then for neon, it's the symbol Ne, and it has an atomic number of 10. So if I wrote 10 here, and an atomic mass of 20.17, then I would know that it has 10 electrons, 10 protons, and about 10 neutrons. So when we're talking about electron configuration, we're just going to discuss electrons. So let's fill out these boxes as if we're trying to model the element neon. So first we have our 1s box, and it fits 2 circles. Then we move on. Now it's full. So now this has become 8. We have 8 electrons left. So then we're going to fill out our 2s, all of the s ones. S fits 2. See how the s and 2 are kind of backwards of each other? That makes it a little bit easy to remember. If s fits 2, now we have 6 more. And p fits 6. So we have 1, 2, 3, 4, 5, 6. Great. So now we have 0 electrons left. So this is awesome. But what if we had an element that had more? So we could erase neon and try a different element. So let me do that really quickly. Why don't I actually just erase and redraw here? So if I have my 1s, 2s, 2p, 3s, 3p, 4s, and then 3d. So let's try using a different element. So I have 1s, 2s, 2p, 3s, 3p, 4s, and 3d. So let's use sulfur. So sulfur has the symbol S, an atomic number of 16, and an atomic mass of 32. So it has 16 electrons, 16 protons, as well as 16 neutrons. That makes it fairly easy. So we can fill this out now. We have S's only fit 2, so we now have 14. We have 2 more and 2s. Now we have 12. And then we can fit 6 in the p. 1, 2, 3, 4, 5, and 6. So 12 minus 6 is 6. So I can fit 2 more here. So now I have 4, and 1, 2, 3, and 4. So now I have 2 blank spots in my 3p level. And if you look at a periodic table, you'll see that sulfur is 2 to the left of argon. Argon would have a full 3p level, and chlorine would have 1 less in the 3p level, and sulfur has 2 less. So you can kind of predict what this electron configuration is going to look like based on an element's location on the periodic table. And just as an FYI, for those of you that are interested in kind of knowing more about that, here's the order for filling the orbitals. It goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, and that's what we filled out so far. But now we can go 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. And S's fit 2, P's fit 6, D's fit 10, F's fit 14. And there's even more information about this, but we're not going to go into that amount of depth in this class.